Hey friends, I'm doing this one podcast style again. I just want to move through it pretty quickly, so I'm trying to just walk in and get it done. So it's unusual. This goes with your doodle notes. These go with your doodle notes. I do not normally do these as slides, but today I really wanted to. Okay. And I'm trying to work my scrolling and it's not really cooperating with me. There we go. So we're talking about chemical bonds. So again, you need your doodle notes paper. You need to be carefully filling this out as you go. So, chemical bonding. Bonds. Atoms bond because they become more stable when they have full outer shells. And you're going to want to pause these as you go so you have time, right? But we've talked about this. Atoms want to be full on that outer shell. They can donate, receive, or share electrons so they can become stable. I'm stable if my last layer is full. The octet rule, 8 electrons in the outer shell. Okay. So an ion is when you have more or less electrons than you were supposed to have, or than you would have if it equaled the protons. We already talked about this here. When plus equals minus, then there won't be a charge. It'll be neutral. An ion is not neutral. An ion is either a positive or a negative. Okay? If you have more protons, you'll be positive. If you have more electrons, you'll be negative. Okay? So an ion has lost or gained an electron. The number of protons can't change, remember, because whatever my element is has to have the same. Helium always has 2 protons, and that's it. It can't lose or gain a proton. That's just a different element. But it can lose or gain electrons easily. So it's an ionic bond when a metal atom donates an electron to a nonmetal, or more than one electron. When we say metal and nonmetal, we mean based on the periodic table, how it's separated, and some of them say that they are a metal or a nonmetal. Okay, sorry for my sniffles. In the ionic bond, the metal one becomes more positive, which is called cation. We remember this because it's positive cats are cute. And the nonmetal becomes more negative, and that's called the anion. Okay, so I remember that because A means like without, like an anemia, it means you're missing something in your blood or things like that. So a good example of this would be like sodium chloride. Sodium is in the metal part of the periodic table. So the sodium becomes a plus, Na+. The chloride, which is not a metal, becomes negative. And it becomes like Cl negative in that interaction. Oh, and it's using that example. I didn't even remember that. So yeah, exactly what I just said. A sodium has that 1 electron that's lonely on the outside. It wants to give it away. Chlorine has 7 on the outside. It wants to fill up. And so they work together perfectly. They're not happy until they can each get that full outer shell. And notice that sodium's getting it by getting rid of a whole shell. It doesn't matter. As long as the outside one is going to be full, it's okay if they have to lose a shell. Okay? You need to mark the cation and the anion. And even these little arrows, they are there on your doodle notes. So that needs to be totally filled in. Sodium is the donor. Donate means to give away. And chlorine takes that electron. Okay. Now both of them have a full outer shell. The Na has a +1 charge and the Cl has a -1 charge. Okay. So now they have opposite charges, and that makes them attract to each other stronger. Now on the other side, a covalent bond, instead of giving and taking, it's when we share. Okay. The pair is there, and it's holding them together because it's basically in both of them. It's basically in both of them. So in the NaCl, I'm going to go back up, don't panic. In the NaCl, they are not in both. This extra little green has just moved all the way over to Cl. But in the case of covalent, they are sharing it. Covalent is, both are not metals, okay? If there's a metal, it's not really covalent. So, for example, here we have NH3, which I think is actually called nitrate or nitrite. We'll have to fact check that later. Nitrogen has space for 3 electrons. Each hydrogen atom shares 1. So they're actually sharing it in this case. We call that pair that's alone on the outer edge a lone pair that only has ones from nitrogen, and we call the ones that have one from each bonded pairs. Okay? Oxygen has space for 2 electrons each. 2 electrons. Each hydrogen atom shares 1. So this is H2O. So previously, I'm going up. In H3, we see this can happen, but it can also happen in a similar way with H2O. So H2O has covalent bonds, not ionic bonds. Covalent bonds. Oxygen has 6 on the outside. And so in O2, each atom is sharing 2 to finish up into 8 for each other. And this is why oxygen in our atmosphere is usually O2, not just O, because they want to do this. They're not happy on their own. Metallic bonds, which we're not going to be testing on that much, but you still should have some idea, is when metals give up electrons, and this forms what we call an electron sea, like an ocean of electrons. And so then you have all these atoms that are positively charged, and they're bonded to this sea of atoms, so the atoms become kind of loose around everything. Here's an example. Okay, so you can see the pluses in the middle, and all these free floating electrons, like an ocean around these. This can happen in metallic bonds. This is a little chart for you. I don't know if this appears on your notes. I think it doesn't. But this is just like a kind of a cheat sheet for this. So what happens to the electrons? What kind of bond is it? What state would it be in? We didn't mention in the slides here, but an ionic bond is usually crystalline solid. That makes sense because NaCl table salt is a crystalline solid. It's a crystal. We know that. Covalent bonds can be a solid, liquid, or a gas. Water is easily a solid, liquid, or a gas all the time, and that has covalent bonds. And metallic bonds lead to a malleable and ductile solid, meaning it conducts things like heat and electricity. Malleable means soft. You can work it with your fingers or a hammer. And we know this is true about metals that have those metallic bonds. Okay? And so this is explaining the different things about this. Okay? All right. So that's all I'm going to do for that. Make sure that is completed and put into your binder. If you have carefully listened this entire time and are still listening, didn't cut me off when I was done, you can come up to my desk and whisper the word ductile, and you will get a coin. Thank you. Thanks for filling out your notes. Keep them safe.